welcome to my talk called JavaScript and similar things for Java developers. First of all, let's make a few things straight. Who believes he's more Java developer than JavaScript developer? Anybody? Okay. Some believe they are double Java developers. Is there anyone who codes more in JavaScript than in Java? Nobody. Okay, so I can say dirty words about JavaScript. Perfect. My name is Jaroslav Tulach. My Twitter handle is the same. I work for OracleLabs on GraalVM. But the talk is not about GraalVM. Only at the end I will mention that. More, I'd like to show something like history of JavaScript, Java, and compare them a bit. If you have questions, feel free to tweet. I'm watching the tweet list on the iPad. I should be able to include answers in my talk. Last month, we celebrated 20 years since the first code commit into the repository that later became part of Netbeans. So yeah, 20 years ago, I basically founded Netbeans. And I was initial architect of that. So I will use that as a historical experience explaining something about Java, which you may not know because it happened in the last century, basically. Then I published an API design book about the API design experience that I gained while designing Netbeans. And I will try to touch about that a bit as well. However, the most significant part of my talk should concentrate on Java and JavaScript interoperability, which I basically started to investigate in 5 years ago, and also on Graal and Truffle interop, because that's what I'm doing right now. You have been warned. Okay, so I will talk about historical things, but if I'm wrong, that's absolutely okay. I will try to focus on speed, because we in OracleLabs believe that speed is important, and then somehow draw some conclusions out of that. So that's the agenda for my talk. So as I mentioned, Netbeans, the first commit to Netbeans happened 20 years ago. But even before that, we used to have a student project at Charles University on mathematics and physics faculty called Xelphi. And it was written in Java 1.0.2. Anyone coded in that version? One. Yeah, okay, of course. It was a horrible version. For example, it had no reflection. So you could not inspect methods and invoke them dynamically. Not at all. But you can imagine that, for example, for IDE, this is exactly what you need to do. You need to inspect components, and you need something like JavaBeans, which was not there at all. So we needed to invent that, somehow solve all these problems. And that usually happens because I think we were the first Java IDE written in Java. Back in time, big companies like IBM with Visual Age, or Sybase with PowerJ, they tried to support Java in their own existing environments written in C++. We were basically the first IDE written in Java. So we finished the student project, and then we basically formed the Netbeans company led by Roman Staněk, and we managed to produce Netbeans 2.0, which was running on Java 1.1. And that was a huge move forward, because there was reflection, there were JavaBeans, and there was some preview of Swing that we could use. And luckily we did that, because later Swing became the default toolkit for the desktop supported by Sun Microsystems. So a year after that, I think to 1998, we released Netbeans Developer 2.x, which supported Java 1.2, and again, we were the first IDE that supported Swing development. So at that time, we basically became attractive, and Sun Microsystems bought us, and then we get open sourced. So meanwhile, on the other side, somewhere, the history of JavaScript began as well. So Java was basically agreed by Netscape as being the language for writing applets. Anybody knows what is applet? Anybody is using applet? One? Okay, yes, so thanks for knowing it. That's a big failure of Java, so I'm glad that you know about it. Basically, applets were the way to deliver code into the HTML, into the browser. But in addition to that, basically Netscape wanted something lighter. So they started a project led by a guy who loved scheme and self. Anybody knows scheme? Okay, few. Self? Even less. Okay, but so scheme is a functional language full of parentheses, and I cannot program in that. But it's a functional language. So basically that means in JavaScript, functions are the primary citizen. And self is a simplification of Smalltalk, which actually has no classes. So each object can have a prototype. Something like an instance can have a pointer to another instance from which it inherits some properties, which is actually what we have in JavaScript as well. So you can, like really JavaScript is a combination of scheme and self. But it has Java-like syntax because that was the condition that Sun required Netscape to do in order to use the JavaScript name. So we have a functional, highly dynamic, no-class language with Java syntax in the browser in 1997. But, well, the fact that the language was created meant almost nothing because it was not functional at all. It's like, if you look at the history, first versions were basically complete. If you write normal JavaScript code these days, it can only be run in Netscape 4.0, not before. And that was something like 6 months or maybe even a year after introducing the first version of JavaScript. But it became popular, and every browser vendor actually had to implement it. But of course, like, it was owned by Netscape. So if Microsoft wanted to implement it, it had to be done incompatibly. And so as a result, we had a language which was slow, incompatible, and really hard to use. Let me check the questions. Why is Netbeans so amazing? A guy from Netbeans community. No, let's skip that. Who cares about Netbeans anyway? So I said it was slow. Compared, well, originally Java also was slow, but then then Sun formed a team of special VM engineers to implement C2 compiler. And actually the team was taken from self language. So we have another point of connection between JavaScript and Java, and that's the self. So like the speed that Java has these days is basically thanks to all the research done in the self language. So Java was slow, was fast at the beginning of this century, almost, but JavaScript was still completely slow. Later, Google decided to fix that. And really, I cannot forget my experience from EclipseCon 2012, when the keynote was delivered by Google engineer working on W3C specifications. And he basically said that they want browser to be a platform. And at that time, I was like looking, platform? Netbeans is a platform, but browser? Huh. But they succeeded. These days, browser is a platform. And one of the key things in that story is that Google invested a lot into the virtual machine for JavaScript, so-called V8 engine. So they hired 50 top engineers that could implement the virtual machine. They worked for a few years, and at the end, they really managed to speed up JavaScript quite a lot. And all other vendors had to catch up. So right now, well, we can talk about the fact that JavaScript is not a programming language, but it's a fast non-programming language. So the speed difference is not there anymore. And I have demo to demonstrate that. If you see my demo last year, then this is basically the same. So this is Sieve of Eratosthenes written in JavaScript. So it has a counter of natural numbers from 2 to infinity, filter that remembers all prime numbers, and then a loop which basically checks if one of the prime numbers divides the current number. If not, it adds it into the list. And then we repeat that in a loop and measure the time. So I can run it in a browser, and that's different compared to what I did last year. Okay, so this is this is the current engine in Chrome. I'm not actually sure whether that's V8 because it's sort of slow. But I'm sure that if I run it with Node.js, Node.js contains V8 engine, and we can get to something like 109, 106 milliseconds to compute 100,000 of prime numbers. Okay, if we do that in Java, and I have implementation of that in Java as well. Implementation, okay. So again, filtering, natural number generator, and then the main prime loop. And again, I can run it either with UI, so generic client code. So this is my one project. It starts, shows the UI. I can start it, and we see that Java is faster, but not that much. It's like maybe 20–30% faster. Yeah, and we can see some variation in there, but the fastest runs are really below 100 milliseconds. The other ones are probably influenced by the UI, because if I run the same application just with console, it should be almost all the time below 100 milliseconds. Oops. Okay. Yeah, it gets below 100 milliseconds frequently. Okay, so I close it. So what I wanted to demonstrate is JavaScript is no longer slow language. It really can run fast. The other thing that I'd like to point out is the standardization. So do you know how Java is standardized? Okay, Volker? JCP. And what is JCP? Well, that's an organization established by Sun and now held by Oracle. So whatever this company wants will happen, basically. Sometimes with some glitches, but that's how it works. On the other hand, JavaScript is not owned by one company. It has been donated to ECMA organization, and its standard is called ECMAScript. And the say there is, well, the companies like Google, Microsoft, Apple, Mozilla have a relatively equal say there. And that's a result that they actually need to make some compromises. For example, there has been standardization of JavaScript version 2, which passed the ECMAScript process. And then they started to put all the nice things into the language, like when the dog and cat by Karel Čapek tried to prepare a cake. So we put there everything, and it failed. So as a result, there is no ECMAScript 3 specification, or well, actually 4 specification, because they could not agree on it at all. Something like that almost never happens in JCP. if the sub-proposal makes it to JCP and it's like proposed by Oracle, then it's almost for sure that it will pass. And it makes a difference. If you know what is Asimo.js, anyone? Nobody. Oh, so that's answer to the question whether JavaScript is a programming language or not. Asimo.js turns JavaScript into a programming target. So you can compile C code into subset, well, actually extra set, superset of JavaScript that uses a special notation. And then it's way easier to run it fast. It has been invented by Mozilla. But the thing is that if you put Asimo.js compiled program into regular JavaScript interpreter, it still runs, just slowly. But if you have a special interpreter that recognizes the Asimo.js like additional features in the program, then it's way easier to make it run fast. And this is the kind of like innovation by extension, but smooth extension that is completely compatible. On the other hand, Java created Invoke Dynamic, and Invoke Dynamic was there to bring in different dynamic languages into the Java platform. But it was done in a way that it completely changed the internals of Java Virtual Machine. And implementing that is problematic if you have alternative Java implementation, Java Virtual Machine implementation. And so, but that could only happen because really the JCP does not need to seek balance between other vendors. Basically, whatever is decided can happen. And as a result, like the evolution of Java is not as smooth as it has been in case of JavaScript. Also, like the robustness is a different thing. So web, actually, if you write HTML, it doesn't matter whether it's correct or not. The browser will render something anyway. And like this kind of robustness is something which is like built into the JavaScript world, into the HTML world. And it's different than in Java when we try to seek correctness. Okay, another thing that I like to focus on is UI toolkits. So in 1998 or even 7, basically Microsoft was a huge supporter of Java. And it was presented as a huge win for Sun Microsystems that they could get Microsoft on board. But soon it turned out that Microsoft actually does not want to write like platform-independent programs. So Microsoft basically tried to put in hooks so the programs could run only on Windows. And Sun Microsystems tried to stop that. And there was a lawsuit with Microsoft that Sun won. But one way of like trying to stop this changes into Java platform was to say you either need to implement the whole Java or nothing. Unless you implement it all, it's not Java. And this actually like slowed down the innovation, slowed down the adoption, because nobody was actually able to re-implement Swing from scratch compatibly. That was, actually that happened, but it was so enormous amount of work. So even like IBM founded Eclipse in 2001 without SWT with different toolkit, because the toolkit was the problematic part. And Eclipse was basically a way how IBM tried to take over of Java from Sun. But even that was too much work. So anyway, Java meanwhile shifted towards servers. So the original client-side vision of applets was way gone. The developments, like the amount of improvements in the browser and in the applet space was close to 0. And as a result, we got the Flash problem, because people started to write applications for the browser in Flash instead of in Java. So the answer to that was JavaFX. JavaFX is a UI toolkit which is supposed to replace Swing. So what would be your first thing to do when creating a UI toolkit? Anyone? Widgets? Maybe rendering pipeline? That's what I would do. But you know what was the first step with JavaFX? We create new language. We create FX script. As a result, like the whole effort completely failed. Version 1 was just horribly bad. And also another problem was that it was not interoperable with Swing. So you needed to throw away all your Swing applications, start from scratch. Basically, little people did that. So then Sun started JavaFX version 2.0, which was better, like really just doing just the widgets, just the rendering pipeline. And at the end, something like 2011, we were there. It's working. And we could replace Flash. The only problem was that Flash was gone at that time from the browser. So actually, we won the battle over Flash, but nobody cared. OK, so let me now describe how JavaScript goes to Java and how Java goes to JavaScript. So the JavaScript has been introduced into Java in JDK 6 with the scripting engine API. And the default implementation for JavaScript was Rhino, taken from Mozilla. So that probably sort of matched what they had in their browser. And it was sort of slow. So in JDK 8, the team decided to re-implement it with an engine called Nashorn, which provides significant speed up. But then what we are trying to do in Oracle Labs is to come up with GraalVM and really speed it up so we can actually beat the fastest JavaScript implementation, which is V8 currently. So let me do a demonstration so you understand the speed differences. In JDK, it took me a long time to find out where to get JDK 1.6 yesterday. Sieve. So if we ignore that it doesn't print new line, you can see how fast it is. I will always press enter so we see the output formatted the way modern JavaScript formats it. OK. Wow. Yeah, here is it. So here is the answer. So basically, this implementation, the Rhino implementation, was capable to compute the 100,000 prime numbers in 20 seconds. Well, no surprise that people at that time considered JavaScript a toy language, because this is ridiculously slow. So what happened in JDK 9? Oh, JDK 8. JDK 1.8, 122, bin, JavaScript. OK. That's way better. So the Nashorn implementation speeds things up significantly. Really, that's way better implementation. But if you remember, with the V8, we were able to get around 100 milliseconds, 110 milliseconds. And that's actually what I believe we can do with GraalVM. So GraalVM is basically Java virtual machine with additional support for writing interpreters for different languages. One of them is JavaScript. So I can invoke JavaScript and let it run. So it optimizes for a while, but at the end, it should get to something that is relatively fast. Slower than V8, but only partially. Definitely something like 2 or almost 3 times faster than Nashorn. So this basically illustrates the amount of work that has been invested in speed of dynamic languages, how to make things faster. Really, 20 seconds, 10 years ago, well, maybe 15 years ago, and now something like 100 milliseconds. Almost similar to Java, almost similar to C. So if we look at the opposite way, how Java goes to JavaScript. So the primary motivation there is that applets are no longer supported. So you cannot use applets in current browsers anymore. The other thing, if you like try to move to browser and run your application in a browser, is do you care about the code or about the data? Because if you care about the code, you probably want types, so you can maintain your application over the period of time. If you just like want to write a script to process some data or handle a user click, that's probably like okay to do with typeless language. But otherwise, you need to supply a lot of unit tests. So the answer to that, usually various transpilers. Again, JavaScript is a like assembly language, it's a target language that can be executed fast. So GWT, TVM, back to browser VM are all approaches that allow people to write in Java and convert it into JavaScript. So you can basically have your type-safe way of programming and still be executed in a browser. And actually, one of the motivations that led me closer to this effort was the task to actually execute Netbeans in the browser. And originally, everyone like suggested that we should do it in a server. So there will be a server running Java, and the browser will display something. Well, that doesn't scale, and that's no challenge. So I decided to do it differently. And here is an example. So if you want, you can go to this website as well. It's called DEW, like Development Environment for Web, apidesign.org, which is my website /DEW. And here we can see various examples. So, I don't know, math for kids. So they are loaded from GitHub. That's Java code. And if I try to edit it, I, for example, get code completion. And this is basically part of Netbeans running in the browser. It does not connect to the server to like compile the code, execute Java code. We took Java-C, transpile it into JavaScript, and we are running here in the browser. But that's not all. Basically, what I can do, I can even run the code. So now the Java-C will generate class files, and the virtual machine, the back-to-browser virtual machine, will start up and will run the application here. So what I can do, I can basically answer, and it's live application, so it reacts. And if I do go here and change something, can I change something here? Let's do something else. So prime number. Okay, so I change something. I increment the number by 1. So now the prime numbers should be shifted. So if 5 is, actually 7 is prime number, so I should say 6. 6 is prime number, 7 is not prime number, just to demonstrate that this really compiles in the browser or when I press this button. So, okay. I should stop a few things, I assume. Okay, this one is stopped. Browser. So we can transpile Java into JavaScript. And that has some benefits because, as Sun used to say, innovation happens elsewhere. And actually the oldest UI toolkit we are using these days, well, which is in really huge use these days, is HTML. HTML is older than JavaScript, older than Java, older than any Java UI toolkit. And it's most portable rendering platform. Again, it renders all the time. And the only thing that they ever had, only problem that they ever had, was the Flash problem. Flash basically killed the browser because until there was a way to write HTML5 in JavaScript, people were just like going the Flash way. So HTML is good. Just the JavaScript help with that to beat the Flash. But well, like we still want better language. So here is small intermezzo on MVC and MVP. So model view controller, anyone knows? Model view controller? What about MVP? Okay, less, But that's basically the same thing. So the best explanation I used to get was originally when MVC was invented, then basically you needed a model which was in memory of the computer. You needed a view. So in 70s, that was a printer. Whenever the computer computed something, it printed it out. And you could take it, go home. And at home, you would use punch cards to program the change of your program or the data. And then the punch card reader would read that. That was the controller. And the whole cycle would continue. So this was the MVC. With MVP, things changed in 80s because then we no longer had separated input, like controller, and output, the printer. We connected them together. We got monitor and keyboard, and you could use it interactively. So then, basically, the view is somehow connected with the presenter, and the interaction changes. But actually, the same way happened to web. Web in the 90s was MVC. You get a HTML page. That was the view. Somebody rendered it. And later, the user could click on a button or URL, and the URL sent a request, or the browser sent a request back to the server. So the URL was the controller. But again, this evolved into MVP with Ajax that allows you to asynchronously query the server while displaying a single-page application. And so these things are basically repeating. The web is reinventing things. But actually, one thing that I have not seen before is Mvvm Pattern. And that's like your application, your model of your application is completely isolated from the UI. The UI is absolutely separate. This is the style that is propagated by JavaScript frameworks like Knockout, Angular. And I would say it's way better than anything we ever had in Java, like Swing, SWT, JavaFX. It's just like nothing. MVV is the way to go. So let me do a small demonstration of MVV. Oops. Okay. Close this one, close this one. So what you can do in Netbeans is to basically choose JavaFX HTML5 application. And by using HTML, it will actually like show the benefits of MVVM. So now what you can say, where do you want to deploy the application? By default, of course, on desktop. But you can package it for Android, iOS, browser, even as a Netbeans plugin. But nobody cares about Netbeans, right? So we will skip that. Anyway, I will install some sample code for the archetype. And now, OK, my application should be generated. It's a Maven archetype, so actually it's not tied to Netbeans at all. Just with Netbeans, it's relatively nicely integrated. OK, and basically two files were open. One is the model. And the model basically says define class data with property message, and with property rotating, with type string, with type boolean, and also a computed property based on the message that splits it into individual words. Then, so this is regular Java. You can use code completion if you want. So you can see that there is the set message, set rotating property, get words property, and so on. But the nice thing, I will put a breakpoint here, but the nice thing is that you can actually refer to these properties from the HTML. So this is the UI. That's the HTML page, which contains the buttons. And by using the data bind syntax, you can actually say that if somebody clicks on the button start, the turn animation on method should be called. So I can do it. I can run the application. So basically, web component should start. And if I click start, I really should be in Java, invoked from the UI. But the model itself is completely independent from the UI, which has great attributes for unit testing. So actually, you can actually test the application in a completely isolated way without referencing to UI at all. So MVVM is, in my opinion, a complete winner. And any future UI framework needs to support MVVM. No, that's not this one. Model, view, model. I don't know what it means. Sorry. Okay. So, and here is my conclusion. So I did all of this just to tell you that people don't care. Actually, nobody wants to write Java and transpile it into browser. Well, it's working. You have seen it working. It really works. It's slick. It gives you MVVM. It gives you all the goodies you could get. And I haven't shown you the debugging capabilities in Netbeans, but people don't care. Rather than that, people learn JavaScript and will use the JavaScript framework directly in JavaScript. Or they like tell the junior guys on the team, like, do it, do the front end. I'm the server guy. Really, nobody cares. And if you are missing types, well, people try TypeScript or Kotlin. And as a result of that, Java is the new COBOL. It's on the server, somewhere in the framework, mainframes, somewhere in the mainframes. Nobody can see it, touch it. You can talk to it with REST API, but it's like, oh. So nobody cares. Well, but if you care about the Java in a browser, we can talk later. I'd be glad to give you a demo how the technology works. And now the questions. Retweet. No questions, just publicity. Publicity is good. Okay, yeah, now basically when we are doing interop between Java and JavaScript, we somehow need to translate API design patterns from like Java to JavaScript and back. So one common pattern is configuration object pattern used in JavaScript, and that allows them to like grow the number of parameters. So what the function perform does, it takes one parameter, which is an object with these properties. And it's easy to add new properties into that object, so you can easily grow the parameters. Otherwise, like this would be hard to do in adding parameters in JavaScript is complicated because you cannot have overloaded methods, unlike in Java. So in Java, you could do it by overloaded methods, but sometimes that gets out of hands. What other option that you have is to create an object with setters and getters. But the problem is that setters don't return the previous value. So this kind of example may get very complicated. So it's better to use builder pattern. And even better to do some like generation of the pattern. So I will not go through the example. I will just show it. If I found it. Builder general code. Okay, that should be it. Builder. Yeah. So actually, again, what you can use is the technology that we invented for Netbeans called HTML/Java API. And you use the model, and you just say, I want builder. And as a result of that, you can actually write code like this. So you create new object, and then you do put, and set the value, and put once again, and then you can take the object and send it into function that takes it. So this is a way how to somehow do named parameters in Java, which are easily extensible. And behind the model, there is annotation processor that basically generates all the code. So you can get the builder basically with four lines of code and 3 lines to really use it. So even with Java, you can actually get as productive as in JavaScript or like as compact. Okay, how many minutes I have? 10 minutes. Time to talk about Node. So the result of the overall success of JavaScript on the client and the fact that Java is now hidden in the mainframes only, and the junior guys are taught to told to write in JavaScript is that JavaScript is entering the server space as well. That is Node.js. Who knows Node.js? Okay. And that's basically a server environment built on top of V8 with native bindings and asynchronous I/O. And in this case, asynchronous I/O is good. It's single-threaded, so and non-blocking. It has to be single-threaded because it's JavaScript. It doesn't handle multiple threads easily. So Node.js is quite popular among the new generation. So what we are trying to do, actually, in Graal organization, in OracleLabs, is to somehow bring the benefits of Node.js and GraalVM and Java together. So you could have speed of both JavaScript, Java. You could have threads. You could have Java interop. And you could use all the Java libraries that you have. So here is architecture of GraalVM. So below, we have Java hotspot virtual machine. On top of that, there is a small interface that allows us to hook in the Graal compiler. And actually, this interface is part of JDK 9. So if you don't know JDK 9, you have it there. On top of that, we add the Graal compiler, which is basically a modern alternative to hotspot C2 compiler. And with that, you can already run Java, run Scala, run Groovy, anything that compiles to bytecode. In addition to that, we also have a special API for writing interpreters called Truffle Framework. And with help of this API, you can write effective and really fast implementations of dynamic languages like Ruby, JavaScript, or R language. And that's not, and of course, if we have JavaScript, why not build a framework that actually is using JavaScript on top of that as well? So basically what we did is we took V8 and Node, and we take out V8 and put there our JavaScript implementation. And as such, basically, you can run Node.js on top of Java. And in addition to that, we have something called Sulong, which allows us to run all the statically compiled languages like C, Rust, C++, anything. And time for demo. And that's good. 7 minutes to go, and this is what I wanted to show you, because that's what we are working on in OracleLabs. So, again, let's start with a wizard, but this time let's do HTML5 JavaScript development, and let's select Node.js plus Java application. Okay, so first thing we need to do is to select, wow, this will look ugly. I restart, sorry. Okay, so let's try once again. HTML, Node.js application. So usually when I switch the resolution, this rendering goes off. So right now it's correct, so that should be fine. So what we need to do is to select GraalVM. You can download GraalVM from Oracle Technology Network. So in the wizard, if you click on this link, you will be sent to Oracle Technology Network site where you can read about how good the VM is. Once I close this, no. Here, download. No, it was APM product. Nah, one more, downloads. Okay, so here you accept the license, and you can get, you can speed up your Java, and you can also get the Node implementation for JavaVM. Let's go next. So it's Maven. Again, it's Maven archetype. So you don't need Netbeans to do all of that. It's possible to do it from a command line. Okay, TMP, GeeCON, Node.js. Okay, and now what we can do is to choose. Do we want a sample that will show us how to write factorial in Java, in JavaScript, in Ruby, in R language? Okay, let's do that all. Now there is an option whether the server should be primarily written in JavaScript or whether it should be written in Java. Because with the Java to JavaScript interop, you can easily use Java to access any JavaScript API. But let's stick with the JavaScript one. This is the summary. So basically artifact ID, group ID, version, and we will create the project. Once the project is created, I can probably start it, or at least show how it looks like. So basically, there are two files. One is the JavaScript Launcher, and the other one is Java. So this is the launcher. It defines the algorithms. For example, in Ruby, what you can do is to use something that we have in our GraalVM, interop API, when you basically in JavaScript tell the system to evaluate something in different language, like Ruby, and it will return a factorial function written in Ruby. Okay, so what I will do, I will put a breakpoint here. So in Ruby, breakpoint, and I should run it. I need to prepare a browser and curl HTTP localhost 8080. Hello, GeeCON. So how are we doing? Listening, fine. So hello, GeeCON. So that's what we do. We basically received a URL. But what I can do is to really compute a prime number. So I will do it like Ruby, 3. Okay. I let it run once because it takes longer time to initialize the Ruby language. If I do it once again, I can do F7. And actually, the debugger brings me into the Ruby language. So I can debug the Ruby part, return back, continue, and work. The thing that I'd like to show as well is there are some differences between the languages. So let me make this bigger. So if I, for example, call Ruby with some large number, okay, I get the precise answer. If I try to do it with JavaScript, and I probably can use even way smaller number, the number will be rounded because JavaScript is using double type. So Ruby. So there is a benefit of like mixing the languages because you get different libraries. The next thing is with Java, actually what we do is we run the computation in background thread. That's basically done by, here in Java, we are using async and await, which is a JavaScript thing like run this somewhere else than in the main thread. JavaScript has only one thread. And await says, OK, return from this position only when the thing is computed. So what I can actually do is to compute a really huge number in Java. Oops, Java. 70,000. And I run it in background. And meanwhile, oops, I can, like the server is handling the request. So I will do JavaScript. So once again, huge Java number, JavaScript. So JavaScript result is computed, and only later, the Java returns back into the JavaScript thread and handles the response. So this way, you can basically combine the power of Java script node framework plus threading from Java, because you can mix it all and you can get the benefits of both worlds. Slides. These are not slides. Here are the slides. No. Here. Okay. Yeah, the boundary problem. Because like if you mix two languages, the problem there is the boundary. When you are crossing from language to another, you need to store the registers, read them on the other side, and it's very costly. But the thing on GraalVM is we eliminate that. We know how to eliminate that. And I have no time to talk about how it's done, but definitely our goal is to show that like all languages can be fast. Boundary problem demo, too late. I cannot do it. So this is how languages look like these days. Like some languages are inherently slow. Ruby, R, it's like 500 times slower than any other language. But what we believe we can do is to really make them fast. Really get them into 1 to 5 time ratio between from the fastest one. Okay, yeah, and the thing that I wanted to talk about, but I cannot, is we have a way how to take your Java application and compile it into native library. It's called Substrate VM, and if you download the GraalVM, there is a command called native image. So bin GraalVM bin native image. And if you use it, you pass in the jar file with class path and a main class, and it will turn that into an executable, which has enormous impact on startup speed. So while Java is relatively slow on start, with the native image, it starts like this. But for some other talk, no, I cannot handle the demo. So the conclusion that I'd like to make is, if you have basically two choices, or well, it's almost inevitable that we need to get polyglot. Somehow you need to write the clients in browser. Somehow you want to write the things in on the servers, and Java is there with a lot of investments. So for a long period of time, we will need to be polyglot. And we have two choices. Either go to the JavaScript. That means transpiling Java to JavaScript and letting the JavaScript being run in node.js, for example, on a server with Java being transpiled there. Or another option is to use GraalVM, because we give you Java Virtual Machine and we give you support for all the dynamic languages like Python, Ruby, FastR. So basically, you get it as well. And actually, there are some limits to transpiling. Some things are really hard, because if you transpile, you actually need to generate JavaScript. And that JavaScript will be then taken by the compiler, like V8 or SpiderMonkey compiler. And only that will be compiled to native code. And doing the JavaScript the way that it's easily understandable by the next compiler it's hard, and it's yet another level of indirection. With GraalVM and Truffle, you actually can directly talk to your compiler. You can really, when you are writing the interpreter, you can tell the compiler, this is a constant. Consider this constant, and I will tell you if it ever gets changed. So things like that are way easier to done with GraalVM. So I think it's a better path to go. And OK. So this is my last slide. I will check the questions, but in any case, you can download from OTN the current version of what we have and experiment with that. It's mostly open source. You can build functional things from the open source, as the Twitter presentation by Chris that was done here in this room before demonstrates. You can mix all the languages, and you can use Java with that. And also, we are still growing. So if you want to work with us, you are welcome to send your CV. Question. Oh, no. Amazing. Did not JavaFX had problems during adoption phase due to EE marketing focus? Well, yeah, possibly. Well, really, a lot of the Java development switched to servers. But the problem is that the JavaFX really the version 1.0 went in completely insane direction, in my opinion. That's probably not the opinion of my employer. Java C in the browser lives. Yes, it did. OK, question. So is HTML the last remaining platform-neutral toolkit for rendering? Well, it's really widespread. And the amount of investment that gets into HTML is huge. Free C committee is coming up with a specification for SVG, for FreeGL, for I don't know what. And all the vendors really need to implement these specifications. And if we basically use what I demonstrated, the transpiling of the Java, which actually I should probably show. No, that's not the right. Here is the browser. OK. So in case you are interested in the technology that transpiles Java into any device and uses HTML for rendering, then visit this website. I contributed slightly to this effort, but otherwise there is a Munich company behind that. So I think like with HTML, if you want to implement JavaFX, basically you need enormous amount of engineers to do all the rendering pipelines, like having scene model, having bits representation, getting to various graphical cards, making it fast, having a fallback if that doesn't work, and so on. And that's enormous effort. And if you just like use Java and connect it to WebView, you get it for free. So whether you have the break. Yes, that is the boundary. Indeed, the boundary is there. Well, if you transpile to JavaScript, there is not a boundary. I can show you a demonstration that it can be relatively fast. But if you do it like 2 VMs, then of course, yes, there would be some delay. But on the other hand, it's UI. So people don't care that much. Like that it looks different. Yeah, but there are some efforts how to mitigate that. Anyway, if you want to talk about this, let's take it offline. Otherwise, I'd like to thank you for your attention.